Hello everyone, welcome to Introduction to Couchbase Lite for Kotlin developers. My name's Aaron LeBeau, and I'm a developer advocate at Couchbase. Let's get started. There are several reasons why you should be looking at using Kotlin to build Android applications. First, in 2019, Google announced that Android features and development would increasingly come to Kotlin first. With Android Studio, it's relatively easy to mix Kotlin and Java code in the same project. Apps written in Kotlin tend to be smaller and have fewer bugs thanks to language syntax and newer frameworks for handling things like running tasks asynchronously with coroutines. Lastly, a Google study showed that converting apps like Google Maps to Kotlin resulted in a 33% reduction in codebase size and a 30% reduction in number of MPE crashes. At Couchbase, we love Kotlin, and our entire team is excited to announce for full support using Kotlin to build Android applications in the next release of Couchbase Lite, version 3. A beta is now available for you to use for testing in your apps. To get started, let's review the agenda for today's talk. First, we'll begin with an overview of the SDK with some code snippets of everyday tasks like opening databases and reading and writing documents. Next, we'll review asynchronous events using Kotlin flows. Finally, I'll show you can get access to some source code of a demo app that you can use to review the SDK in action. Let's get started with an overview of the Couchbase Lite SDK. The Couchbase Lite SDK makes it easy to plug in and use in your new or existing Android applications. It is distributed via Maven and has been architected for performance while using a small footprint thanks to the storage engine and data storage layer. Now let's look at some code snippets to see how you can quickly use the SDK to do frequent tasks. Let's look how to open or create a database using the Couchbase Lite SDK and compare the syntax of Kotlin to Java. On the left, you can see that we have 3 lines of Kotlin code, and on the right, you can see we have 4 lines of Java code. When comparing the two implementations, they look almost the same. If you've used Java in the past with the Couchbase Lite SDK, you'll find it trivial to start using Kotlin in your apps. The Couchbase Lite SDK requires initialization by passing the context to the Couchbase Lite init function before calling any other API. The Couchbase Lite init function call only needs to be made once for the lifecycle of your application, and an exception will be raised if any other Couchbase Lite APIs are invoked before the initializer. You can create a new database or open an existing database by using the database API. When calling this API, it will check if the database exists on disk, and if not, you'll create the database and then open it. One thing to watch out for creating or opening a database is asynchronous process, and it's best practice to use coroutines to ensure it's running on the dispatcher IO thread instead of the main UI thread. You can use the database configuration factory create function to initialize a new database configuration object that you can provide to the database API to define the directory location of the database. Finally, when you call the database API, you can give the database name and the configuration object in the function call parameters. The database variable created then can perform various functions like reading or writing documents to the database. For enterprise developers, database encryption is an important feature. The Couchbase Lite SDK can use encryption to secure data at rest when it's stored on the device. The algorithm used to encrypt the database is 256-bit AES. Database encryption key must be provided as part of the database configuration object to tell the database API to use an encryption key when opening or creating the database. As you can see in the code snippet, we've modified the code to pass in the encryption key via the encryption key function to the database configuration factory create function. Again, comparing the Kotlin code to Java, we see the code is very similar. So now that we've shown that Kotlin API is very similar to Java API, let's take a look at how documents are stored in the database. Couchbase Lite stores information in the database in documents. The document format that Couchbase Lite uses is JSON, which stands for JavaScript Object Notation. JSON documents can store a wide range of values, including numbers, strings, booleans, arrays, nested objects. Every document in the database must have a unique way of identifying it called the document ID. Note that once the document ID is created, the ID cannot be modified. Couchbase Lite uses reserved metadata attributes to track various features like document version and replication status information inside the documents when created. These attributes start with an underscore like underscore ID and underscore rev. Because Couchbase Lite uses underscores at the beginning of its metadata attributes, I recommend you do not start your attribute names with an underscore. Now that we've looked at how the documents are stored, let's look at some code snippets on creating, reading, updating, and deleting documents. Let's look at 2 ways you can create a document using the Couchbase Lite SDK with Kotlin. First, we create a mutable document object on the left by passing a unique ID. I'm using a UUID in this code snippet, but you can use any string value as long as it's unique. Second, once the mutable document is created, you can use the set method to set the key and the value for the attribute you want to store. In this code snippet, we are storing strings, dates, booleans, and even blob values. Finally, we use the save function on the database variable to save the document to the database. Another option for creating documents is to use Kotlin serialization library like JSON from Google to take database class objects and serialize them to JSON formatted string. Once you do this, you can use a mutable document constructor that takes in the document ID and a JSON string to create a mutable document. Finally, you use the save function, just like in the code snippet on the left, to save the document using the database API. To read a document from the database, you'll need to know the unique ID for the document. The database API provides the getDocument function that takes a string value of the document ID and returns a document object. Once you have the document object, you can read values from the document in one of 2 ways. The first way is using the key value pair as a code snippet on the left shows. The other way is to use serialization, like the example on the right, to deserialize the JSON string to a Kotlin data class object. Now let's look at how to update and delete a document from the database. To update a document, you need to know the unique document ID. Like the read document example, we use the getDocument function from the database API, which returns a document object. The document object is immutable, which means we cannot change its value. However, the document object does have a toMutable function that will convert the document to a mutable document. Once you have a mutable document, you can use the same key pair value functions as shown earlier in the create example to update the attributes. To delete a document, you need to get a reference to the document using the getDocument function from the database API. Then you call the delete function from the database API, passing a document reference as a parameter. Couchbase Lite supports a SQL-like query using one of 2 options. The first option is to use a fluent query builder syntax that allows you to construct queries. The second option, new in Couchbase Lite 3.0, uses the NQL or N1QL syntax to query the database. For more information on NQL queries in Couchbase Lite, I recommend you check out the Connect Talk, Introduction to NQL for Mobile, Enhanced Queries for Couchbase Lite. To query the database using a new NQL query support, we use a database API createQuery function and pass in a string formatted NQL query as a function parameter. Finally, we call the query API execute function, which returns a collection of results back. You can use a for each loop inline function to loop through the results and process them. Couchbase Lite supports 2 types of indexes: value indexes and full-text search indexes. Indexes are critical database performance, and you should create one anytime you use the where clause in a NQL query. For example, in the previous slide, we saw a NQL query that used a where clause to find a document of type project. Without an index, the Couchbase Lite API would have to look at every document, expecting the field to see if the value is equal to project. If we create an index on the type attribute, the Couchbase Lite API can use that index to quickly find any document and check its value, making your application faster. Couchbase Lite does support full-text search queries. However, unlike NQL queries, you must first create a full-text index before using the full-text search query API. Couchbase Lite supports a database replication between a local database embedded on your app and a remote Couchbase server. This replication uses the Couchbase Sync Gateway server to communicate between the mobile app and the Couchbase server. The Sync Gateway and Couchbase servers can be in your data center or the cloud. Replication is very flexible. You can configure it to pull or push and run on continuous or one time. Couchbase Lite support for pre-built databases means you can preload your app with the data. One benefit to this approach is reducing the consumer wait time on initial install and launch of the application before showing data and not waiting for data to sync. The prepackaging of data typically applies to public shared, non-user specific data that is mostly static. However, even if the information is not static, you can still benefit from preloading it and syncing the changed documents on startup. The initial sync of a pre-built database will pull in any content changes on the server that occur after its incorporation into the app, quickly bringing the database up to date. Before using a pre-built database in your application, I recommend checking out the complete documentation on our documentation website. With that, let's look at some snippets of code that use a pre-built database. It's usually best practices on the Android platform to compress the pre-built database into a zip file and put it in the application's asset or resource folder. In the code snippet example on this slide, we first check if the database already exists. If it doesn't exist, we need to calculate the location to save the database when we will extract it from the zip file, which in this example is stored in the location db path variable. Next, the unzip function goes through and unzips the database from the locations.zip file. Once the database is uncompressed, we need to calculate a full path to the database file on the device, which is stored in the locations db file variable. Finally, you must make a copy of the database using the database copy function. This function generates a unique ID for the database file that is used during the database replication. Let's suppose you didn't use the database copy function. In that case, the Sync Gateway server would see the instance of your application installed on various devices as the same database, thus invalidating checkpoints. Now that we've reviewed the essential Couchbase Lite APIs, let's look at a more advanced topic of asynchronous events with Kotlin's asynchronous flow. Asynchronous events in Kotlin are handled via the Kotlin's coroutine API. A coroutine is an instance of suspendable computation. Coroutines are similar to a thread. However, a coroutine is not bound to any particular thread. A coroutine scope keeps track of any coroutine you create. In Android, there are Kotlin libraries that already provide coroutine scope and certain lifecycle classes, such as viewModelScope and lifecycleScope. The coroutine context includes a coroutine dispatcher that is used to determine what thread or threads the coroutine uses for its execution. Dispatchers.io is a commonly used dispatcher that is a shared pool of on-demand created threads and is designed for offloading I/O-intensive blocking operations like file I/O and blocking socket I/O. The coroutine's flow API is used to collect a stream of values. A reminder that flows are a cold stream. They do not run until the flow is collected, and they run on a context that collects the data. If not set up properly, you could run your flow on the main UI thread, which can cause performance issues. Developers new to coroutines and Flow API should review the official Kotlin and Android documentation provided on their site and the links below in this slide. The Couchbase Lite API provides flow implementations for several events, including database change. It will calculate any document that's been updated in a given database. Document change will calculate when a specific document has been updated. Live query will calculate when there is a change in a query result set. And replication status will monitor the current status of replication. In the code snippet example, we have a function that returns a flow of a query change object. The query is set up with a nickel query that filters out the documents in the database that are of type project. Next, the query is executed, and finally the flow is returned. In this example, there is no data transformation done in the project flow function. Instead, the flow is returned, and it's up to the code that collects the query change to loop through the results and use the documents that are provided. For those developers that are concerned about separation of concern between our code that queries the database versus our code that does business logic or talks to the UI, there's another way to handle this. The Kotlin Coroutines Flow API provides several intermediaries which we use to modify the values that are emitted into the stream. One such intermediary is the map function. In this code snippet, rather than returning the flow of a query change object, we return a flow of a list of projects. In this example, before executing the query, we define the inline map function, which calls a private function that maps the query change to a list of projects. The map query change to the project function loops through the query change results and uses the toJSON function on each result to deserialize the result into a project DTO object that then adds the item property of that object to a list that is returned. By using the map function, we can separate our code that serializes information from the database from the code that does our business logic and presents the information to the UI. The document change flow will calculate when a specific document has been updated. This example should look very similar to the live query example with one noticeable change. As you can see highlighted on the slide, we use the flow_on function to set the flow to run on the dispatcher I/O. This makes sure that the code uses the database runs on a thread group optimized for file I/O. As discussed earlier, it's important to remember that the flow runs on the dispatcher that collects the information from the flow. If this was a view model that was running on the main UI thread, this could cause performance problems. By using the flow_on function, we can make sure that the code that reads from the database runs on the proper dispatcher. In the replication status flow example, we return a replicator change object from the flow using a replicator API's replicator change flow function. The collection code inspects the change to see if the status of replication and logs the information. Now that we've reviewed some of the basics of the various asynchronous flow APIs in Couchbase Lite, let's go over the inventory demo app. The inventory demo app is a modern Android application written in Kotlin and uses Jetpack Compose, the new UI framework that greatly reduces the amount of code it takes to display UI elements on the screen. The app also uses popular methodology between the UI and data access layers via patterns like the repository, view model, and mutable state. The full application code is available from GitHub at the URL provided in this slide. Finally, the inventory demo app requires Couchbase Lite 3 beta for Kotlin in order to access all the APIs we talked about today. Let's do a review and look at the code inside of Android Studio. Before we can open the application up in Android Studio, we need to first download the code from GitHub. I have the GitHub repo open here, and we have the README file open with some directions. I wanted to point out that in order for you to run the application, you will need a newer version of Android Studio, Arctic Fox. This is because Jetpack Compose has newer libraries. It does require this newer version. On top of that, you need Android Builds Tools version 29. Now, this is usually required to ship apps to the Android App Store now already, so you should already have it on your computer. Also, you do need the Java JDK 8, and that's usually a minimum requirement for Android Studio. We do have build instructions built into the repo here that explains how to do this. On top of that, we have a link to both the Android documentation and the Sync Gateway documentation on the Couchbase Docs website, which have been updated for the beta so that you'll have full documentation for Kotlin support. Also, on the website here inside of the repo, I'm going to go to the wiki page. And in the wiki page, we have a full list of documentation that breaks down how to do everything inside the repo, including set up Docker images so you can test replication. To find these, you can use the navigation menu over on the right. For example, I can go to the manual setup, and this walks you through all the steps that it'll take to build a Docker image for both Couchbase Server and Sync Gateway. So you can test this with the mobile app, syncing back and forth to the server through Sync Gateway. Before I show you the demo of the application, I'd like to show you some sample data and explain how the application works. I currently have Couchbase Server open via Docker. Now, the directions on how to set up Couchbase Server and Sync Gateway, once again, are in the repo and the wiki section. I'm going to go into Buckets and then select the Projects bucket and go into the documents for that. You can see here I have a bunch of documents were preloaded into the database. I'm going to go ahead and select Warehouse 100. I want to show two particular fields inside of this, or attributes inside of this document. To start out with, the team attribute is how I'm handling security in this demo app. You can see here this document is set to team 1. Now, users are assigned to a team, and because of that, we can do security. In Sync Gateway, the security feature is called channels, and we can have a custom script go through and set the channel that the document actually is published on based on the team that is set. By doing this, we can emulate security by saying only users in a certain channel or team can see these documents when they come from the server down to the mobile device. On top of that, when I create documents on the mobile device, I'll automatically set the team inside of the document based on the user logged in. Let's look at this metadata to validate that this is actually how the document's been set up. We look at the metadata, it's been modified by Sync Gateway. And you can see here that the channel is now set to channel.team1. And this is because of the fact that Sync Gateway ran, saw these documents, and processed them. This also means the first time you start Sync Gateway and you have a bunch of documents on your server, it does take a little bit of time in order to process those documents. The Inventory Demo app is an application that simulates inventory audits. Inventory audits are broken down into projects, and projects have a location and a due date that are assigned to them. Let's look at the data again inside of Warehouse 100 to kind of show this off. As you can see here, we have a name of the project. We know that the type of document is project. We know that the due date of this document is set to December 31st, 2022. We can see here that there's a location associated with this particular inventory audit that's going to happen, and we can see then a team has been assigned to it, along with when it was created, and then the unique ID for this particular document, which is the project ID. Now let's look at the Inventory Demo app running on both a physical device and an emulator. In order to do this, we need to log into the application. I happen to have the local authentication service up and running the code here in Android Studio. I want to kind of show you that here are the users that we have for the application, and here are their particular username, passwords, and the team that they're assigned to. So we can see here, demo@example.com is set to team 1, along with demo1@example.com. But if we look, demo2 is set to team 2, along with demo3 is set to team 2. And then, of course, we have demo4 that's set to team 3, and finally, demo5, who's also set to team 3. And this is how I described the security works inside of the application. Now, of course, in a realistic application, this would probably be done via some kind of authentication service, OAuth, some other provider. But for demo purposes, I've hard-coded these users inside the application. I'll go ahead on the physical device. I'm going to log in as the demo user. I have no projects to start out with inside the application. There's a couple different ways you can add projects to the application. The first is by using the floating button plus sign to click the form that comes up and add a project into the system. The project needs a name, a description, a location. Now the locations are set up via the DB copy. The locations actually are in a zip file database, and when the application first starts up, I make a new project database using the locations database. So all the data you see in locations came from a pre-built database, which is kind of neat, and it actually runs really fast. This data doesn't change that often, so it totally makes sense to actually put that into a pre-built database. Finally, you can do a select a due date by selecting the control here, and it'll bring up a calendar control, which you can select the date. Now, this is one way to add data to the app, but it's pretty boring to watch me add a bunch of data there. So instead, I'm going to use the developer screen inside the application to go through and add a bunch of sample data. To get to this menu, you hit the hamburger menu, overflow menu on the upper left-hand corner, tap the developer option, and now there's a couple different options. On the developer screen, the first thing I want to point out is that it shows you which users logged in, it shows you what team they're part of, and it shows you the database that it created by copying the location database. So you can see here in this particular user, I have project team 1 as the name of this database. I'm going to go ahead and click the button that says load sample data. And it's that quick. The data has been loaded into the database, and then it shows up on the screen. The reason why it shows up on the screen is because of the fact that I have a live query running on the database with a query that goes through and selects any projects that have been added to the database. And this is all random data that's been generated. You can look at the source code to see this. Any one of them that you see in red means that it's overdue. Now, I can sync this data to the server and get the particular documents on the server that's been pre-uploaded via the script to make sure that the phone is up to date with the server. In order to do replication, we need to go into the replication configuration screen. How to get there is using the hamburger menu, clicking the replication. Now, on the screen, you can see here that replication isn't configured, so we need to use the cog icon to configure replication. You'll see here at the very first, we need a URL for the particular Sync Gateway server. Now, this is the IP address of your laptop that's running Docker that has the Sync Gateway server installed on it. On my home network, my IP address of my laptop is 192.168.1.250. On your network, it could be a different IP address. So you need to go into your computer, look up the IP address of your laptop, and replace it with that particular IP address. If you don't, this will probably not work. Don't use my IP address. Now, replication type is interesting. We have a couple different options. So one, we have push and pull, which means we're going to push documents on the device up to the server, and then we're going to pull any documents that are configured with the proper channel and team down to the mobile device. If I wanted to, I could just do a push, which means I'll just push documents up to the server. Or I could just get documents from the server by doing a pull. I'm going to leave it to push and pull. Continuous is a setting that allows us to say we want replication to continue to happen over and over again, as long as the application's in memory. If you only want to do a one-time sync, you actually could turn that flag off. I'm going to go ahead and click Save so we can start replication. Replication runs pretty fast. In fact, I'm going to click the Start button, and by the time I'm done, it'll be done. And it's that fast. Replication's been done. I can go back to the main screen of the application and show this off. We can see here we have our audit documents, and if we scroll, we can now see also our warehouse documents. We have warehouse 100, 101, and 102. On top of this, we should be able to go to the server and look at the the documents on the server and see that our audit 383636 document has made it up there. So let's go to our server and check that out. I'm going to go ahead and retrieve the documents again by clicking the Retrieve Documents. We can see here we've got right here is our 383636 document. Now, if we go through and edit it, we can see that this is our sample data. We go look at metadata. We can set that it's set to Team 1. And we know now that this document has come from my mobile device up to the server. And we got documents from the server onto my mobile device. And it was actually pretty easy and fast. Now that we've done that, let's take a look at it on an emulator to see how it works. I have the emulator up and running now with the application logged in as demo4 at example.com. We can see which users logged in by selecting from the hamburger menu the developer screen and reviewing. We can see here this is demo4. We're on Team 3. And the database that was created was called Project Team 3. I'm not going to load sample data. Instead, I'm just going to do the replication process to get the documents from the server. To do this, once again, we're going to go into the cog icon, validate that the IP address is correct for my particular laptop that's running this. I'm going to leave the rest of the settings the same and just click Save. I'm going to click the Start button, and replication is now done. I click the hamburger menu, and we should be able to see there is our warehouse 300, 301, and 302. I'd like to thank you for attending this talk on an introduction to Kotlin for Couchbase Lite 3. For more details and information, please follow the links to the repo and check out the wiki, as there's a great breakdown of how the entire project structure works, along with some links to videos that'll explain how to go through and debug the application. As always, you can reach out to social media and use our forums if you have any questions about either the demo application or if you have questions about Couchbase Lite in general. Thank you, and take care.